Hello. For these testing, it's a proportion, and so you want to open in Chapter 9 the Excel hypothesis testing for proportions, and then we plug in here where the gray is. So if we read this, 20% of all college students volunteer their time. Is the percentage of college students who are volunteers smaller for students receiving financial aid? Of the 386 randomly selected students who received financial aid, 73% of them volunteered their time. Now, is this study we should use a z-test or a t-test? It's a z-test because the sample size is large and it's a proportion. So we can use a z-test. The null hypothesis, if it's a z-test, this is p, sorry. This is always equal to. And then it was the estimate you were given, which was 20%. And they want to use the decimals. It says right here, please enter a decimal. So you do want to see, sometimes they ask for the percent, sometimes the decimal. But the null hypothesis is always equal to. Now, it said we wanted to test if college students is smaller. So smaller would be less than. So everything else stays the same. It's P and 0.2, and this will be less than. Test statistic, again, is Z. And to find the rest of this, it will come over here. So we just fill in. Level of significance, 0.05. Sample size, 386. The number that said yes, 73. And population proportion, that comes from your null hypothesis. That's the 0.2. Test statistic, right here. The negative 0.534. The p-value is right here, and we were testing less than from the alternative hypothesis over here. Less than, points left, so it's this one, the 0.29652. Now they want to know if the p-value is greater than or less than alpha. So this was our p-value, 0.296. Alpha was 0.05, so the p-value is definitely greater than. If the p-value is greater than alpha, fail to reject. Fail to reject. The data suggests the population proportion is not significantly lower. Because we're rejecting it, it's not lower. There's insufficient evidence to conclude the percentage of financial aid recipients who volunteer is lower than 20%. There we go. Try one more. A news article that you read stated that 60% of voters prefer the Democrat candidate. You think the actual percent is smaller, so again we're testing less than. 150 of the 282 voters that you surveyed said that they prefer the Democrat. What can you conclude with a 0.01 level of significance? So again, it's a z-test because our sample size is large. Then we have p equal to the 0.60. Again, it's a decimal. And then we were testing less than, so p less than the 0.60. To find the rest of the values, we plug them in here. Our level of significance was 0.01. Sample size 282. The number that said yes, 155. And population proportion 0.6. Test statistic, Z equals negative 1.726 right here. We were again testing less than, so it's a left tail, so it's the 0.042. So that would be here. Then we look to see if the p-value is less than or greater than alpha. Alpha was 0.01, p-value is 0.04, so it's definitely greater than. So again, we fail to reject. P-value is greater. Fail to reject. It is not smaller. The data suggests the population proportion is not significantly smaller, so we cannot say the proportion of Democrats is smaller than 60%. When you're using the p-value, you're going to write it as a percent. That was, so it'd be 4%. But you're basically saying the same thing. The population proportion of voters who prefer the Democrat candidate is 60%, and if another 282 voters are surveyed, then there will be 4.22% chance fewer than 55%. So it's telling you the chance that it could be less than, and it's a 4.22%. And then the level of significance tells you if the population proportion of voters who prefer the Democrat candidate is 60% and another 282 voters are surveyed, then there would be a 1% chance that we'd end up falsely concluding it. So that one tells you the chances of getting it wrong.